All right, and we're here with a couple of examples. I'm going to do Power Standards Quiz 27 and Power Standards Quiz 28. A couple of examples from each of those. So the first one I have on the screen is from Power Standards Quiz 27, where it says, in the given graph of a function, what is the independent variable? And in any function, we have an independent variable and we have a dependent variable. And this is kind of based on the ordered pairs, or what you need to know first or versus what you need to know second. And the independent variable is what you need to know first. It's the variable that comes first in a function or in an ordered pair. So in this graph, we don't have an x and y axis. We have a b axis right here, and I know that because of this b right here. And we have an a axis because of the a right there. And in an ordered pair, we go left or right first. We do the horizontal axis first, and then we do the vertical axis. So if I was to plot points, this would go in the order of b comma a. I would go along the b axis first, and then along the a axis. And the independent variable is the variable that comes first. What do I need to know first? What is independent of what's happening second? In a context, this would be easier to answer, but in the language of algebra, the independent variable is always the variable that comes first in an ordered pair, and in this case, it is the variable b. b comes first, and then a depends upon b. You can't say what the value of a is without knowing what the value of b is first. And in a context, that would make a little bit more sense, but in the language of algebra, it is just the variable that comes first in an ordered pair. Power Standards Quiz 28, we're asked if a table represents a function, or if the table that we see here is a function. And when we talk about functions, functions relate one input to exactly one output. So when I look at this input here, and the input is the x value because that comes first. The input is the x value and the output are the y values. And I have 5 to 10, I have 6 to 12, I have 7 to 14, and the relationship from one to the other isn't really what's important here. It's whether or not each of the inputs go to exactly one output. So 5 to 10, 6 to 12, 7 to 14, 5 to 13, 8 to 16. And the two I'm going to look at here are this value and these values. So 5 to 10 and 5 to 13. And I'm highlighting those because when I put in 5 the first time, I get 10. Now how I get from 5 to 10 isn't important. It's just that I go from 5, I put in 5 and I get out 10. And then all of a sudden I come down here and I put in 5 and I get out 13. And there's a conflict there. If I put in 5 the first time and I got out 10, then when I put in 5 again, I should get out 10 again. And that does not happen. And if that does not happen, then the table does not represent a function because I'm not getting the same thing for each of the inputs. I put in 5 and I get out 10, and I put in 5 and I get out 13. Therefore, this is not a function because of the input 5 has two different outputs. If this 13 here was a 10, or if this 10 was a 13, then this would represent a function. But since I put in 5 twice and I get out two different things, it is not a function. This one here might say it's not a function because we see a whole bunch of negative 2's here. But notice all of our inputs here, none are the same. I put in 2, I get out negative 2. I put in 3, I get out negative 2. I put in 4, I get out negative 2. None of these inputs are duplicated, unlike that last example. So therefore, this is a function because each input has exactly one output. Each input goes to a certain output, and all the outputs can be the same. Nothing wrong with the outputs being the same. Each of the inputs give us exactly one output. So there's no duplicated inputs here that can kind of raise a red flag to say, well, maybe that's not a function. So this is a function because each of the inputs has exactly one output.